Hey, good morning, guys. Today we're going to be doing a lesson in the complex numbers. So we're going to start by warming up. So let's simplify these. If you would like, please stop the video, copy these down, and simplify them. Then come back to the video and check the answers. I'm going to be working them for you, okay? Remember, remember that you need to when working these, you need to start from the most innermost parentheses, working your way out. And I'm going to show you how to do it. Just pay attention. Okay, and that's how you get it done. All right, so today's lesson, we're gonna start here. This is what you need to know. What you will learn today is define and use the imaginary unit, I, and subtract and multiply complex numbers. Find complex solutions and zeros. Okay, so the imaginary unit, I. Not all quadratic equations have real number solutions. For example, x squared equals -3. Has no real number solutions because the square of any real number is never negative number. So what they're trying to say here, just so I translate it in layman's terms, is x squared equals -3. If you are to solve for x, you would have to find the square root of x squared equals the square root of -3. Okay, and that means x is whatever the square root of -3 is, and that has no real solution. Let me give it to you in easier terms. Everybody knows that the square root of 4 is either 2 positive or -2. So it's 2 or -2. That's the square root of 4. So the question is, what is the square root of -4? Well, if you answer 2, well, cannot be, because 2 times 2 will give me 4. And if you say -2, well, -2 times -2 is not -4. It would still be 4. So there is no possible real solution for finding the square root of -4. So we had to come up to overcome this problem. Mathematicians created and expanded systems of numbers using the imaginary unit, defined as I, which I is equal -1, or I is equal the square root of -1. Note then that I squared equals -1. The imaginary unit I can be used to write the square root of any negative number. So out of all this, the most important part is that you understand that the square root of -1 equals I. So that, make sure you have those in your notes. That means that since the square root of I squared is I and the square root of -1 is I, that means that I squared is -1. Okay, so that they're defined. That's what the most important part of this whole page is. So make sure you have it. Okay, so let's take a look at example 1. They give me the square root of -25. Well, the square root of -25 can be written, because this is the same thing as -1 times 25. According to the rules of radicals, then this is the same as the square root of -1 times the square root of 25. Therefore, I already know that the square root of -1 is I. We just learned that. So that's I. And the square root of 25, at least the positive part of it, is 5, right? So the square root of -25 is 5i. Pretty simple. Now, let's take a look at one that is not a perfect square, because 25 is a perfect square. What happens to what is the square root of -72? Well, the square root of -72 can be split into the square root of -1 times the square root of 72. We already know this part. This is I. But what about 72? Well, what you want to do is you want to simplify it. So you want to break it into its prime factors, okay? Okay, so breaking it into its prime factors, that means I need to break this. I just need any 2 factors. I'm going to pick, for example, 9 and 8. Because 9 times 8 is 72, correct? So then I break this one apart and I say, well, that's 3 times 3. And then I break this one apart. This one is 2 times 4. And then this one apart. This one is 2 times 2. Okay, so now that I have my prime factors, I notice that if I write it out, I could say this is 2 times 2 times 2 times 3 times 3. That means all these prime numbers, 2, 2, 2, 3, 3, will multiply to be 72. And we could verify that. Do 2 times 2, which is 4 times 2, that's 8, times 3, 8 times 3 is 24, times 3 is 72. So 24 times 3 is 72. So these are the prime numbers that will make 72. Okay, so a little story. Anytime you get married, you have a couple with you, hey, you want to get out of the house. So if you look at it this way, let's make this my house. If you have a pair, you need to be out of the house because you ain't living with me, right? You already have your mate. Get out. So here is a pair of 2s. I'm going to put that 2 out here. Outside. Now, here is a pair of 3s. So I'm going to put those 3s out here as well and multiply them. And then the square root of -1 is I. So I'm going to put that one there. Now, notice there is one here that has no pair. It's by itself. So however many you have when you are breaking out a number, well, however many you have that do not have a pair, put them inside. So this one goes inside. If you had another one, you put it inside and you multiply it 2. Okay, so then we do the last operation, which is multiply. 2 times 3i, that's 6i. And then the square root of 2 is an irrational number, so just leave it like that. So the square root of -72 would be 6i square root of 2. All right, pretty simple. Now let's take a look at this last one. We have -5 outside. We have here is the square root of -1 times the square root of 9. Well, the square root of -1 is I, so this already -5i. And what is the square root of 9? 3. So multiply that times 3. So 3 times -5i is -15i. And that would be my answer. Okay? All right. So you try the next ones here. You try these. Pause the video. Make sure you work them, and then I'll work them for you. So here we go. The square root of -4, that's a perfect square, so that is the square root of -1 times the square root of 4. This is I, and this is 2. So the answer for the square root of -4 is 2i. The square root of -12, again, you want to take that 12, break it apart. We know that the square root of -1 is I. So that's 2 times 6, and that's 2 times 3. Notice there is a pair of 2's, right? So these 2 come outside. So 2i square root of 3. The 3 stays under. So that's my answer right there. Here is another one. We have a -1 outside, so I'm going to put that -1. I have the I for the -1 inside, so -1i. And then I have the square root of 36. Oh, that is a perfect square. What is the square root of 36? 6. Okay, so -1i. -1i times 6. That is -6i. And you're done. Last one here. You have a 2. You have the I for the negative, right? Then you have that 54. Well, let's break it apart. We take 54 and we break it apart. What is 54? 9 times 6. The 9, I could break it into 3 times 3. The 6, I could break it into 3 times 2. All right, so here is a pair. So that 3 comes out, so we have 2i times 3. And then notice these 3 and these 2 do not have a pair. So I'm going to open my house here and I'm going to put them in here. 3 times 2. Okay, so what is 2i times 3? That's 6i. And then inside the radical is 3 times 2, which is still 6. So my answer, 6i square root of 6. So I hope you did well, and let's continue. A complex number in its standard form is said to be a plus bi. So that's what you need to learn. A complex number in standard form is written in this form, a plus bi, where a would be your real part and bi would be your imaginary part. So this is your real part right here. That's the real, or When I say real, I mean that it's in the real number system, and BI is your imaginary, meaning that it is in your complex number system. So the whole number, this complex number, a plus bi is to be in the complex number system. If b is not equal to 0, then a plus bi is an imaginary number. This is what this is right here, or it's in the complex number. If a is equal 0, that means that you have nothing here, you only have bi, then that is a pure imaginary number. That's what we saw here. These are pure imaginary numbers. Notice that a is not there. The only thing that is showing is bi. The a, that's 0. Since it's 0, 0 plus 2i is 2i, so we don't write it. See, so that's a pure imaginary number. However, here's a table that shows if b equals 0, then you have a pure real number. Here is your imaginary number, and here is your pure imaginary numbers. Okay, so make sure you study a little bit the table and see what's happening so that you can comprehend it. Moving along. Two complex numbers, a plus bi and c plus di, are equal if and only if a equals c and b equals d. That means the real part equals the real part, and the imaginary part equals the imaginary part. That's basically what it's saying. The real part right here equals the real part, and the imaginary part is equal to the imaginary part. So let me give you an example. Equality of two complex numbers. They gave me find the values of x and y that satisfy this equation that they give you here. It says 2x minus 7i equals 10 plus yi. Well, the real part is right here because this is a plus bi, and this is c plus di. See how that works? So now that I know that, the real part, 2x equals 10. To solve for x, I just divide by 2. So 2x divided by 2 equals 10. Divided by 2, x equals 5. So there we have the value of x. In here, negative 7i equals yi. If I divide by I on both sides, notice the i's will always cancel. So this cancels there, it cancels there. So I have that negative 7 equals y, or y equals negative 7. And you are done, my dear friends. So let's go for the next. Let's do these. You try those. Pause the video, work them, and then come right back, and I'll show you how to do them. So the real part equals the real part, so this already solved for this one. X equals 9. About 3i equals negative yi. Remember, the i's will cancel, and it will give you that 3 equals negative y. So y equals negative 3. So that's your answer for that one. How about here? Well, you have 9 equals negative 2x. Divide by negative 2 on both sides. The x, the negative 2 cancels, gives me 1x equals negative 9/2. Okay, the other one is your imaginary part, or your complex part. So you have 4yi equals 3i. Reality, if you notice, I don't have to write the I write it so that you see that is the imaginary part. So you have 4y equals 3 divided by 4 divided by 4, so y equals 3/4. And you're done. X and y, that makes this true. Okay, moving along. Sums and differences of complex numbers. I'm going to show you here real quick how to do that. So let's take the first one. We have 8 minus I plus 5 plus 4i. Imagine this was x. Well, it works the same way, so do not be afraid. You already know how to do this, okay? You already know how to do this. This is the simplest one. So you can only add what is alike. So like terms. It's like combining like terms, what we did at the beginning of the lesson today. So we could, since this is a plus, I could clear the parentheses. I could say, well, this is 8 minus I plus 5 plus 4I. Once I clear the parentheses, I combine like terms. 8 plus 5, that's 13. Negative I plus 4I is negative 1. I plus 4I is 3I. So that should be the answer for the first one right here. Okay? So let's take that, put it there, and let's go to another one. Let's go to the second one. Look at the second one. The second one, there is an extra step because there is a minus sign right in front of that parenthesis. So notice you're not adding, you're subtracting. So it means the opposite of everything in here. So let me show you what you want to do. 7 minus 6I minus 3 minus 6I. Okay, so to clear the parentheses, what you want to do is you want to say, well, this is the same as 7 minus 6I, and then this negative goes there. You see, you change that to a plus. Change that to a plus. And then take the opposite. Negative 1 times 3 is negative 3. Negative 1 times negative 6I, that's positive 6I. Now I could just clear the parentheses. Look. Oh, let me erase that. I could just say 7 minus 6I plus negative 3, so minus 3 plus 6I. So the parentheses is cleared. Now I could put together 7 minus 3. That is 4. Negative 6I plus 6I cancels. So my answer is 4. Okay. Here is this last one. Let's put it together. We have 13 minus the addition of 2 plus 7I plus 5I. I want to clear that parenthesis, so take into account this negative. So 13 plus, so negative times 2 is negative 2. Negative times positive 7I, that would be negative 7I, close parentheses, plus 5I. Now I could clear the parentheses. 13 plus negative 2 is minus 2, minus 7I, plus 5I. So 13 minus 2, that's 11. Negative 7I plus 5I, that's minus 2I. And at that time, you are done. Pretty neat. Here is a real life problem. Most of the stuff working with complex numbers, you're gonna see that in computer work, electronics. You're gonna see that, quantum mechanics, things like that. So if you're gonna go into that field, you need to know this. It's very important. Okay, here's an example for solving a real life problem. Electrical circuit components such as resistors, inductors, and capacitors all oppose the flow of current. This opposition is called resistance for resistors and reactance for inductors and capacitors. Each of these quantities is measured in ohms. The symbol used for ohms is the upper Greek case letter omega right here. Here they give us a table with the symbol for resistor, the symbol for inductor, and the symbol for capacitor. Here is a series circuit. We have the alternator. It flows out, it goes through the inductor, then it goes through the resistor, then it goes through the capacitor back to the alternator to form a complete circuit. Okay, let's see what's the problem. The table shows the relationship between a component's resistance or reactance and its contribution to impedance. A series circuit is also shown with the resistance or reactance of each component labeled. The impedance for a series circuit is the sum of the impedances. So the impedance is the sum of the impedances for every individual component in that circuit. And then it says find the impedance of this circuit. Okay, so look at the table. For the resistor, we have 5 ohms as the resistance right here. So this will be 5 ohms. For the inductor, the resistance would be 3 ohms. And for the capacitor, it would be 4 ohms. Now, if we go to the table, the impedance in ohm will be whatever this is the same for the resistor. So this will still be 5 ohms. For the inductor, notice that whatever this is, you're going to have that imaginary unit. So this will be 3I ohms. And then for the capacitor, that will be negative 4I ohms. Okay, so if we're going to add these, because we want to find the impedance, so we have 5 plus 3I plus negative 4I. Okay, so what we have is we have to add the real part. There's only one, so that's 5. And then the imaginary part, 3I plus negative 4I is 3I minus 4I. That would be minus I. So the 5 minus I ohms, that is the impedance of this circuit. And basically, that would be the answer, okay? That is an example for you. The next example is multiplying complex numbers. When multiplying complex numbers, you treat it the same as you treated when you're multiplying regular expressions. So if you had x in it. So this one is 4I times negative 6 plus I. So remember, you need to distribute 4I times negative 6. That would be negative 24I. And then 4I times I, that would be positive 4I squared. One thing you need to remember is that we learned at the beginning that I squared equals negative 1. Since I squared is equal negative 1, then we have negative 24I plus 4 times negative 1. Well, negative 1 times 4, it just changes the sign. So when you have this, once you learn it, then you understand that just this changed to minus 4. So because you have to write it, the answer, in the standard form, which is a plus bi, that means the real part needs to go first. So that negative 4 needs to go first. So even though you end up here like that, you have to switch this. So you have to say negative 4 minus 24I. That's your answer. Take a look at this one. We got 9 times negative 4. That would be negative 36. We have 9 times 7. That would be 63, or times 7i. That would be 63i. Then we have negative 2 times negative 2i times negative 4. That would be positive 8i. And then we got negative 2i times positive 7i. That would be negative 14i squared. So if I simplify this, negative 36 plus 63i plus 8i plus 14. Remember that negative 1 will change this sign to positive, or the opposite, and clear that I square. Okay, so now all I have to do is put together the real parts. So negative 36 plus 14, that's negative 22. And then we have 63i plus 8i, that would be 71i. So there's your answer, negative 22 plus 71i. All right. Okay, for these, well, you're going to try these on your own. What if, in example 4, which is here, what is the impedance of the circuit when the of the circuit when the capacitor is replaced with one having a reactance of 7 ohms. So the capacitor is this symbol right here. So this one right here, instead of being 4, it would be 7 ohms. So I'm going to start you up here. This right here is 5. This right here would be 3i. And this right here would be negative 7i. And we want to know what is the impedance. Remember, you just have to add them, complete these, and let's get ready to go. The rest of the exercises are on Big Ideas. Go to your assignment and you'll find your assignment there. Okay, any questions? I'll see you in class.